Hello everyone, welcome back to another video. So this is the fourth video of STL playlist, and in this video we will discuss what stack is. So stack is a data structure which is used to store uh, elements which follows a property LIFO. What LIFO means? Last in, first out. Stack basically means this property only. If you understand this property, you will also understand what stack is. So let's say we have a data structure like this, and if we insert an element, let's say I insert 5 in this, it will be stored at like this. Now if I again insert 2 in this stack, it will be inserted like this. So whenever I am inserting an element, it will go to its top element, go to its top. Now the opening, this is a, I would say, simulation of stack. Now we can only access the element from this opening. That means we can only access its top element once. So the point here I'm trying to make here is, let's say I have inserted n elements in my stack. So first, if I have to get the value n, I can just take it from my stack, take it from top of my stack. So the time complexity for it would be O of 1. That means I don't need to do any operation, just take from the top. Now to get the value which is at present at 1, how can I get this block? So for that you have to first pop this n, then pop n minus 1, then pop n minus 2, then pop n minus 3 up to 1. So get 1, we require n steps, so we can call it as O of n. So the property of stack is, whichever element was inserted last will be popped first, or will get out first. In this example, the order I am inserting elements is 1, 2, 3 up to n, but order I am taking out elements is n, n minus 1, n minus 2 up to 1. That's it. This property is enough for explaining this whole data structure. Now I will try to explain. We will directly see the code and its implementation. So first of all, how to declare a stack? I can declare a stack with stack keyword, and then in this brackets I have to declare the object's data type, or if it's a nested object, I have to declare what type of object it is. Now let's say I have to push a value 1. So to insert elements, I have to use push keywords. Now in this case, what would be the so stack would look something like this. So first one was inserted, so it will be at bottom. then 2 was inserted, and then 3 was inserted. So 3 would be at the top. So to print any value which is at the top, I have to use top method. So as you can see, I got 3. Now to remove an element, let's say I have to remove, we can only remove the element which is at top, because we don't have any access to all other elements, we only have access to its topmost element. So before printing the top element, what I will do, I will use pop method to remove the topmost element. Now as you can see, the value was 2. The value which was printed was 2, because after inserting 1 2 3, the stack was like 3 2 1, but after popping, stack became 2 1. If I pop it again, let's say, so 1 would be printed, because after in first pop 3 will be removed, and in second pop 2 will be removed. And all these functions are of1 functions. If you try to implement this using vector, you can also do it very easily with insert. Whenever element is inserted, you just insert to you just push back element to the vector, and if you have to pop that element, you just pop back that element. And from these 3, there are also 2 functions which are st.empty, which will return true and false if the stack is empty or not. So currently there is 1 in the stack, that's why stack is not empty. And similarly I can just push, I can also print st.size. So these 5 functions are only there, and all 5 functions have time complexity of 1. Now you will say, what its use, why what type of questions are asked on this on stack. So let's just see one of the most basic questions of stack, which is valid parenthesis. So we are given a string s, and which contains opening brackets, closing brackets, opening curly braces, closing curly braces, opening square bracket, and closing square bracket, and we have to determine if a string is valid or not. Now a string is valid if open brackets must be closed by same type of brackets, and open brackets must be closed in correct order, and every closed bracket has a corresponding open bracket of same type. Now let me just explain the problem first. Let's say this is my input string. Now for this curly braces, there is this closing curly brace. Similarly for this square bracket, opening square bracket, there is one closing square bracket. Similarly for this square bracket, there is an opening square bracket. For this opening bracket, there is this closing bracket. Similarly for this opening bracket, there is this closing bracket. So this string is valid. Now I will just take some examples from this. So this and this. So for this opening bracket, there is a closing bracket. That's why the answer for this case is true. Similarly, there is this case. All the brackets have corresponding closing bracket. And for this case, For this opening bracket there is no closing bracket, and similarly for this closing bracket there is no opening bracket. Now similar case would be this is also one of the edge cases, not edge cases but cases where we have to print we have to return false, because for this closing bracket this opening bracket should be there, but it will get matched with this first, so that is an issue. And simpler definition of this valid parenthesis would be if we put any arithmetic operation between each bracket, if it forms a valid arithmetic operation or valid arithmetic statement, then this then I can say then the string would be valid. So let's say in this case, if I just put 3 plus 2 over here and 6 plus this plus 4 over here, so this is definitely not a valid bracket, because for this square bracket there should be a matching square bracket over here. So I hope you understand this question. Now what we have to do is, for each closing bracket we have to just compare it with its previous not used open bracket. Why not used? Because for this case, let's say I'm at this position for open bracket, closing normal, closing circular bracket, there should its previous not used bracket is this open bracket, so both of them are equal, same. So I found a closing bracket for this opening bracket for this bracket. Now I will move to next bracket, and now for this case, and to find its previous bracket which is not used, so it is also a square bracket, then I will move to next, and as string is processed I will just return true. So this is a standard problem of stack, and I will try to explain its code. First of all the elements are characters, so I will declare a stack of character. Now I will iterate over string. Now let's say it is current brace is an opening type of bracket, opening. So if it is an opening bracket, what I will do is I will just push it in my stack, and for else, that means for each element which is in closing bracket, I have to find its previous not used bracket. Now its previous not used bracket will always be at top position, because stack is an last in first out type of data structure. So let's say if I'm at index 5, the topmost element would be pushed, the topmost element would be the element which was present at index 4, because it was recently pushed means there would be an opening bracket at index 1 also, but it would not have been recently pushed if there was another opening bracket encountered. So at the top there would be a character stored which was recently encountered, opening bracket which was recently encountered but not used. So first of all, if the stack is empty itself, that means I don't have any opening bracket to match this closing bracket. That example would be the string of length 1 r. Is there condition given that string is odd? No, but let's say a string starting with and closing bracket itself, we don't have any matching opening bracket before it. So in that case answer would be false, and to consider that condition I'm just writing if the stack is empty itself, then I will just return false. Now if stack is not empty and current character it's, let's say, this closing bracket, that means the matching previous character which is not used should also be its opening bracket of same type, and if it is not of same type I can just return false. So I have to write this for all three types of bracket. And finally, after processing all this, so what we are doing is, if it is an opening bracket we will just push it in the stack, and if it is in closing bracket we will just check its previous not used opening bracket. If it matches with the type of the current bracket, I will pop that element. Popping means basically we are declaring that this is used. Now its previous would be not used recently added character. I have to here return if st.size. I have to return true if and only if I can just directly return st.empty, because there might be additional characters like this. So for this closing bracket this opening bracket was matched, but so this type of scenario, not this, where for this closing bracket this opening bracket was matched, but for this opening bracket there is no closing bracket. In that case the stack size would be not 0, means that is also and not a valid parenthesis. So I'm just returning st.empty, because if stack is empty it will return true, else it will return false. So this was the easiest question I would say of stack. Now we will try to do a medium level question. Not medium, this is the easy question because there are less constraints, but let me try to explain this concept. I hope you have understood this valid parenthesis question. Now let me explain what this concept is. So this is I would say I have frequently used this concept on code forces. I will also link you this question. This is an 1800 level question. So first, what is next greater element? Let's say I have given an array 3, 5, 6, and 9. So I just took a increasing, then 5, then 2, then 8, then 11, 1 and 11. So for each index in this element, what I need to find is I need to find its next greater element to its right, first element which is greater than the current element to its right. So for 4, its next greater element is 5, which is its uh, rightmost element itself. For 5, the next greater element would be 8, because 2 is not greater than 5, but 8 is greater than 5. Similarly, for 2, 8 itself is the greater element. For 8, 1 is not greater, 11 is greater. So I will just insert 11. And this answer for 8 would be 11. For 1, it is 11 itself. And for 11, I have to write -1 because there is no element to its right, which is greater than 11. So I have to find this using stack. Now, first brute force way, let's just take the so size is 6 and elements are 4, 5, 2, 8, 1, 11. Now for each element, what I will do, I will store its next greater element. So first brute force way of n square. Now for each I, what I will do is I will iterate from it. I will start iterating from its right element. I will store I don't need to store, but let's say I store an index of, if a of j is greater than a of I will store j in idx and break. I will update nxt of I as idx. Instead of idx, I can store its value. Yeah. So this is the output as we have discussed. This is the desired output. What I'm doing is I'll start iterating from its rightmost element for each I. So I will start iterating from I plus 1 to n, and I will just check if a of j is greater than a of I. Then if it is, I will just store it in idx and break, and finally just update nxt of I with a of idx. Now the complexity for this is n square, because for each I am basically trying to find I'm iterating over the vector itself. So two nested loop, so n square. Now how can we use stack property over here? So let me just write the array itself. Coming up with this solution without knowing it is difficult, so I will just explain the solution to you. First of all, for 11 my answer would be -1, but when I will start iterating from right side and I will maintain a stack. I will maintain a stack, and for first case the answer would be minus the last element would be -1 itself. Now after putting -1, what I'll do is I will push the value 11 in my stack. Now when I'm at one position, when I'm processing this element, I will check, I will try to remove all the elements in the stack which are less than 1. That means while st dot top is less than equal to a of I will pop that element. That means 11 is not less than ai, so then I will break from this while loop and mark whatever top was remaining as its next greater element. So here it was 11. Now similarly for 8, and after marking 11 I will push 1 to my stack. Now while processing 8, what I will do is I will first remove all the elements which are less than 1. So I will remove this 8, then mark its next greater mark the next greater element at as st dot top. So this would be 11, and then push 8 over here. Now for 2, again I will run this while loop, but it will break in first condition itself, and then I will mark st dot top for 2, which would be 8. Then for 5 again I will push 2. Now for 5 I will run this while loop, so it will pop this 2. Then I will push 5. Now before pushing 5 I will mark 8 as its next greater element, and for 4 while loop will be broken at first iteration itself, and it will mark 5. So now if you try to process the values stored in stack, would be 4, 5, 8, 11. Now what is this? It is the increasing subsequence which has its last value, which is the greatest which it is an increasing subsequence. Now how this stack property helps in this question, in this scenario, because for 2 the next greater element would be 8 or 11, but I don't need to consider this one, because before this one there is an already one element which is greater than 1 itself. So if this is an greater element for any of the previous values, its previous 8 can also be 8 will also be greater than all those elements, because 8 is greater than 1, and if let's say x is smaller than 1, then a by a greater than, if a is greater than b and b is greater than c, I can just say a is greater than c. So I don't need to process this one for further. So for whichever elements I'm processing next, it's st dot top, that means 8. would be its next greater element. And this while loop will run, uh, total summation means total number of times it will run would be n itself. So not every time n, but sum of uh, sum of iterations which will it will make for all the i's would be n. So overall complexity would be for I n, for iterating from last to first element n, plus this while loop, which will reduce to be of n itself. So for using this concept, using stack, you can solve this next greater element problem. So I will just write the code for this. Of n, then what I will do is I will declare a stack. Now for this condition, uh, for 11, what I will do is I will just declare I will just push and a value which is very much greater than all the elements. So I will just push int max first. Now I will start iterating from last element and write this while loop, that is while st top is less than equal to a of I will just pop these elements, and then I have to declare another update the next greater element for I with st.top, and then finally pushing the current element. We got same results, just this is an identifier for there is change only in the identifier for its next greater element. If I would have just made it like int max, so int max basically means that there is no greater element for that next greater element to its right for such elements. So we got both the results same, but this complexity of using stack, we got we got the solution in O of n complexity, but in brute force we got it with O of n square. Now the proof for this, the summation of number of iterations which will this while loop make will is n, because this will at most run at most this while loop will run at most the size of the stack, and the size of stack would be max n, because I'm just pushing a of I, and I just n minus 1 to 0 means I'm pushing all the elements, and the stack size would at max go to n. So we can say that this will at max run n times. That is the proof. Now this question has some additional information. You can also do this in brute force, but I would suggest you try with both methods. And there is also second version of this. and in this case you have to use stack because n square will not work. So I will suggest you try both of these questions. Similarly, there is this question. So this was asked in 914 due to. Now in this first part of this question, this itself is in 1600 problem. You need to first resolve the problem into next greater element statement and next greater element problem statement, and then you have to solve it. So in D1 brute force will work, and in D2 you have to use next greater element using stack. Now only you can also find next smaller element, similarly previous greater element, previous smaller element. For finding next smaller element, what we have to you have to do is just add greater than sign here, and at start you push -1. Now if you see, for 11 there is no smaller element, for 1 there is also not no smaller element, for 8 smaller element is 1, for 2 is 1, for 5 is 2, for 4 is 2. So you got next smaller element. If you don't have the condition of strictly smaller, you just remove this equal sign, then we have removed the strictly smaller condition also. And if you have to find previous greater or previous smaller, you just start iterating from 0 to n. So I will suggest try all four configurations and solve all three problems. I would say if you don't solve this, it's okay, but at least solve these two problems, because when I was solving this question, I kind of forgot this concept of stack, and I just submitted a brute force and gave up. But after that, I learned this next greater element concept, and I have remembered it after that. So I think that's it from my side. I will also upload next videos as soon as possible. Thank you for watching.